All right, so let's start with example 3 here, and we're gonna use the chain rule to find the derivative of this function. First of all, we see that this function seems kind of odd because we have a square root, right? But this is a perfect example where we have to use the chain rule. Remember that the square root can be written, the function square root is the same thing as x to the 1/2, right? So we should probably do the first thing is to do is to rewrite this in a power form. Okay, now you can recognize that here the next thing is to recognize that this is the inside of the function and this right here is the outside of the function. So think about having, because you have the outside function, a power function, then you have to use the power rule, right? So we're gonna go ahead and do that. Let's take the derivative of this. FYI, maybe we should rewrite this as the function of g in the power form, right? And then we're taking the derivative of this, then this will be n times the inside function left alone minus 1 times the derivative of the inside, right? So in this case, we're going to take the derivative of this, right? The 10 in the front is just a coefficient which is just carried over. But so when we do the derivative of the outside, will be bring down the 1/2, leave the inside as it is, or maybe I'll leave it that like that. Leave the inside as it is, and then multiply by the derivative of the inside, right? So if you guys think about that, we just did the derivative, the chain rule. All we gotta do is go back and set up and bring back the inside. All right, so we just gotta do the derivative of the last part, right? This fraction, right? This function, but we basically take the derivative. We just left the last one as a note, right? We can multiply those two together. 10 times 1/2 is 5. And then I forgot here, I did a silly mistake. This is supposed to be a negative 1/2, right? Because we took away, we brought down the 1/2, but we gotta take away 1 from the 1/2, right? 1/2 minus 1 is negative 1/2. That's why this is negative 1/2. The derivative of the last part is 10 times the derivative of x to the 6, which is 6, using power rule, 6x to the 5th, plus 7 times the derivative of x to the 9, which is 9 times x to the 8th, right? And that's it, right? We found the derivative. Of course, we're going to go ahead and rewrite it in a much nicer way. This has a negative power, so we're going to bring this down over as a denominator. So we're going to write it as 10x to the 6 plus 7x to the 9th raised to the 1/2. The 5 stays on the top because that doesn't have a negative power. And we're going to multiply by this factor, which is 10 times 6 is 60 times x to the 5th plus 7 times 9 is 63 x to the 8th, and that's it, right? So remember that you have to put a parenthesis because that was grouped together, and we're almost done here. All we gotta do now is rewrite the denominator in a radical form. The rule of that is kind of like, if you started with radicals, then you want to leave your answer in radicals, right? So we change that back to the square root, and that is the derivative of f, right? So the calculus part right here was right here, right? This was the calculus part. Everything else after that, from here to here, was algebra. Right? After that was algebra. So I hope you guys found this helpful. Please let me know if you have any questions. See you next time.